In this video, we're going to be looking at a washing machine NTC. As you can see, this is quite a small device, and this sits internally to the heater and sits between a rubber grommet. Now this is off a Beko washing machine, and the Beko technical says at 25 degrees we should expect a resistance reading through this of roughly 5k ohms. So I'm currently measuring the air temperature in the room, and we're at about 20 degrees. So as this is an NTC, as temperature increases, resistance decreases. So as we're slightly below 25 degrees, I'm expecting to find a resistance of greater than 5k ohms. So I'm going to switch over to my multimeter onto the ohms setting, and I'm going to test the NTC for continuity. So as you can see, the connections on an NTC are very small, and it can be very difficult to get your multimeter into there. So when I test an NTC, I've got a little multi-plug with bigger connections, which make it a bit easier to test. So I'm going to test it for continuity, and as expected, I'm expecting to see it greater than 5k ohms. So that's fine. As expected, it is greater than 5k ohms because we are slightly below the 25 degrees benchmark set by the manufacturer. What I've also got is I've got some heated water, and I'm going to put the NTC into here. As this is a washing machine NTC, it's okay for the end of it to go into water. So as you notice, this is heated water. So as the temperature of the NTC increases, you should notice the resistance on the multimeter decrease. So I'm going to show you that now. So as you can see, the resistance is coming right down. This water was boiled out of the kettle, so currently at the minute it's probably at about 80 degrees. So this is just a visual, so you can see how an NTC operates. So as the temperature increases, your resistance comes down. And as it reaches its peak and starts to cool down again, you should notice the resistance start slowly creeping back up. So as you can see, that resistance is coming back up as that's slowly getting back down to room temperature. Now that can sometimes take a while as metal absorbs heat, so it needs to dissipate that heat it's absorbed from the water. Now that's a healthy NTC, I'm happy with that. I'd be happy to fit that to a machine, and if I was investigating a temperature issue on a washing machine, that's been ruled out as a good component. If you are investigating a temperature related issue on a machine, start with the NTC, that's the first place to start. Failing the NTC, you then move on to the wiring, so you check your wiring from your NTC up to your control module to check it for resistance. If you are getting resistance, then the wiring is okay, and you move over to a control fault. Now, NTCs, similar to washing machine elements, can become coated in limescale, which can insulate the resistance, and it can insulate it so it's not quite reading the right temperature. Now, normally that doesn't cause a major issue, but it is something to be aware of. If you look at this one here, you can see it's starting to get a coating on it, but that's not going to cause a massive issue. So that's how to test an NTC, and that one's a healthy one.